Solving systems of linear inequalities. Let's just show another example here. We're going to graph these two inequalities. Y is greater than negative 2x plus 2, and we're also going to graph y is less than or equal to negative 1. And what we're going to do is attack both of these separately. And the first thing you want to do is graph the line y equals negative 2x plus 2. And when you graph that line, you'll notice it's already in slope-intercept form, where the slope, well, just a reminder, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. So in this case, m, or the slope, is negative 2, or you can write it as a fraction, negative 2 over 1, so that you have rise over run. And the y-intercept is 2. So that's where it crosses the y-axis. Now to graph that one, we'll need our x and our y. So here's the x, there's the y. And we know that this line crosses at 2. So there's 1, there's 2, 3, 4. It's going to cross at 2 right here. And it has a slope of negative 2 over 1, or negative 2, which means you rise negative 2 and you run 1. So rise, and you start at your y-intercept. So start at 2, you go down 2, because that's your rise, negative 2, and then run in the positive direction 1. And that'll get you another point on your line. And now you'll be able to draw the line. And before you draw the line, look back at the inequality, and you'll see that it's a greater than. And since it's not greater than or equal to, that means that the line isn't part of the solution. It's everything greater than that line. So to indicate that it's not part of the solution, we're going to draw that line as a dotted line. So it'll look something like that. And since it's not part of the solution, we need to show what is part of the solution. And the way we can do that is plug in a point that's not on that line. And I always like to try 0, 0, because that's usually an easy one to plug into. As long as it's not on the line, I use that one. So when you plug 0 in for y and 0 in for x, you get this. 0 is greater than negative 2 times 0 plus 2. And that can be simplified as 0 is greater than, well, negative 2 times 0 is just 0. So it's 0 is greater than 2. Is that true? Well, no, it's not. 0 is not greater than 2. 0 is less than 2. So this point is not part of the solution as well. So the line's not part of the solution, and that point's not part of the solution. So what is part of the solution is everything on the opposite side of that line. So everything over here. And it keeps going. Everything over here. Okay, so that's the first inequality. Now the second inequality, y is less than or equal to negative 1. So we want to graph the line y equals negative 1. And this is pretty easy to do. Y equals negative 1 is going to be a horizontal line where y is negative 1. And since it's less than or equal to, we're going to make that a solid line, because that line is part of the solution. Because the inequality is y is less than or equal to negative 1. So anywhere where y is negative 1 is part of the solution. And you'll notice any point on here, the y value is negative 1. So at where x is 0, the y value here is -1. So 0, -1 is a point on the line. Also, if x was, let's say that's -10, y would also be -1 here. So that point, -10 and -1 is on the line. Y could be 100, it could be 1,000, but I mean, x could be 100 or 1,000, but y is always going to be -1 on this line. And then we have to decide which side of this line are we going to shade in on. So the easiest way to do that, plug in a point that's not on this line, and 0, 0, again, is not on that line. So we can plug 0, 0 in. And some students will get confused here because there's no x value. Well, if there's no x value, that actually makes it easier. All we have to do is plug in the y value. So it's going to be 0 for y, and you get the statement 0 is less than or equal to -1. Well, is that true? Well, no, 0 is not less than or equal to -1. 0 is greater than -1. So this point is not part of the solution either. So we need to shade in everything on the opposite side of that line, which is everything below it. Everything below it. And our final solution is going to be everything that's overlapped between our first line and our second line, which is going to be everything over here. Everything over here. That's going to be our solution. Okay, I hope this is starting to make a little more sense. We can show another example in the next video, one where we actually have to play around with the inequalities before we graph them. So watch that one because you will run into a couple new issues with that one.